friends, and welcome to the Adventures of Blink. I'm, of course, Blink, and you can find me on GitHub right here. Now, if you find this content to be useful or helpful or even just plain fun, I want to make sure you give me a like. That lets me know that you're enjoying the content and that I need to do more things like this. And if you really enjoy the content and you really want to dig in further, then I suggest you also click subscribe, because that's going to make sure that you're notified of any upcoming episodes. So last week we looked at a broken test. Well, maybe not completely broken, but it kind of worked, but it had some problems. There were some issues we needed to resolve. In particular, we found that we were testing someone else's code that we didn't have any control over. And so we learned about using mocking as a technique to prevent ourselves from being held up by unexpected behaviors and external dependencies. Today we're going to talk about how to resolve the Phantom Dependency. So here you can see some code that actually just runs fine. See, I get the it works, and I got an output of an Excel file. So everything's operating exactly the way we want. It's beautiful, right? Now let's imagine that we've been asked to make a change to this file. Management has decided that they want to push this out in front of customers or something, and they want the message to be more professional than it works. We'd like it to say something like, report successfully generated. So let's make the change. We'll come in right here. And this is a really innocuous change, right? It's really simple to do. And so report successfully generated. And we can even leave a little note there that output.xlsx is the name of the file that they can expect. Okay, and like we talked about last season, we want our git commit messages to be verbose. We want them to be easy to read and understand what's going on. So we'll do git commit more professional output message. All right, we've made our change and we're ready to push. So git push. Okay, so we've pushed our code, and now we're just going to wait for the CI to tell us that everything's fine. Except it isn't. Wait, this code worked locally. Why does the CI think that I forgot a dependency? This is what we call a phantom dependency. It's something that your code depends on, but it's not in your requirements.txt. Now let's take a look at what's in requirements.txt, and maybe we can start to suss this out. So you can see pandas is the only thing that I've listed in requirements. I thought it was the only thing I needed for this project, but it turns out that the toExcel method, which you can see right here, is actually a part of OpenPixel, and it requires that extra package that I didn't realize. So why would this work on my machine even though I didn't have the dependency in my requirements? Well, as it turns out, I had installed OpenPixel before for some other project, and it was a time when I was in a rush and I wasn't thinking clearly about keeping things separated, so I didn't create a virtual environment to work in, and that meant that I had this library floating around in my workspace, and I was able to use it because it's there, and Python goes, oh, look, I can find the library. I'll just use it and everything's great. But that leads me to a place where as I'm starting a new project, I don't have access to those libraries, or I shouldn't have access to those libraries anymore unless I ask to bring them in. So now I'm starting to build things on dependencies that I didn't realize I had. It's important to use continuous integration tools like GitHub Actions to validate your code, because it does so in a clean environment. If you're ever going to run the code anywhere except on your own space, running it through a system like that means that it's going to get evaluated in a way that helps you understand what's required to hand it off to somebody else. And this is really important when we're sharing code, because otherwise we're going to get trapped in this cycle of looking for all the libraries that I needed. So how would we fix our problem with OpenPixel in our current project? Let's go take a look. First of all, I could come in here and I could run pip freeze. And I'm going to make my terminal a little larger here so you can see that take over. Okay, and it's going to tell me all the things that are currently in my workspace. Now, I could just do something like pip freeze and send it to requirements.txt. But I don't necessarily want that because I don't know that I want all of these things to be passed into whatever library that is. This is technical debt, so to speak, that I've accumulated by not using virtual environments occasionally in the past. And so this is problematic behavior for me. What I really want to do is just identify the things that I absolutely need. So in this case, I know I need OpenPixel. And so what I'm going to do is copy that in here and drop it right like that. Now I have grabbed the library I need, right? So now instead of doing that, I'm going to cancel this back out. And we're going to do a git commit updated requirements to include OpenPixel. Okay, and we'll do a git push. Now, when we go over here, we can go to our GitHub action, and we'll see that it's running. And let's see how our test shakes out. There we see the installs happen. I see everything's finished. We've moved in there, we've run. Guess what? We now have a successful test. That's what it looks like to fix a phantom dependency. So quick disclaimer, yes, I realize that was a very simplistic example. There were only 2 libraries in the requirements.txt file. There were no other dependencies to worry about. The actual code that we're looking at was like half a page long. I realize that it's very, very simple. I did this on purpose because I wanted you to see what the steps are, how to identify that phantom dependency and find it and put it in place and make sure that it's part of what you're doing. It's not necessarily vital that you see all of the clutter, but it's important to understand that when you do this in the wild, you will encounter clutter. A requirements.txt can have hundreds of entries in it. It can have all sorts of different problems, and it could stem not necessarily from the package itself, but a version of the package. So something even more subtle and insidious to have to go track down. These bugs are sneaky, and it's important to realize that. That's why I wanted you to see a quick, easy, simple example, and then hopefully you can extrapolate that to apply in your own world. Some coaching moments that I think I would add on to talk about how to deal with phantom dependencies. First of all, you can eliminate the possibility of them in some cases by focusing on virtual environments. Always work in a virtual environment. Build it out every time. Make that part of your standard like muscle memory for creating a new project, that it's going to be done in a virtual environment. And that way you know what those things are. It actually simplifies the fix if you do encounter one later, because if you're in a virtual environment, you can do the pip freeze and pass in the requirements.txt and create it that way. And that would be a lot simpler than trying to manually enter, 100 different items that you needed. But maybe if you're going to add 100 libraries to your code, it would be important to know a little bit about what those are. And so you should at least be reading over that as it grows and keeping it up to date on a regular basis. The other behavioral thing you can do here to solve for this kind of problem is exactly what you just saw. Create some testing that takes care of that for you. And the moment your test fails to install, because it's always going to do that in its own isolated environment, it's not going to know what you assumed. So phantom dependencies will show up immediately. You'll be able to identify them, highlight them, and immediately track down what's causing the problem. So staying ahead of things in that manner is really important as well. The last thing I would suggest is just remember that you can't trust your local setup. There will always be odd things that pop in and out and weird stuff that happens. And even somebody who tries really hard to keep it clean like I do, I try to keep it as simple and clean and as unassuming as possible. things will creep in over time, and there's really nothing you can do about preventing those. You just need to be aware that you can't necessarily trust it works on my machine. So keep those things in mind and look for ways that you can simplify your dependency management, because managing dependencies is a major part of software development. All right, that wraps up episode 4, and my gosh, we are flying through this season. I hope you're learning as much from this experience as even I am. The act of preparing to put these videos out each week really pushes me to challenge some assumptions, to think about better ways to make the work that I do more accessible to my teammates. That's the empathy we want to build. Not just that, I'm a fantastic software engineer and I can make all this stuff and it's awesome. We all want to believe that about ourselves. But what's really valuable is being able to hand off what I've done and let somebody else take it the next mile. Let them add on to what I've done and make it easy for them to contribute in that way. Because that's how things get better, is we all contribute to the same thing and work together on it. So I'm just going to call it off there. I hope you've had fun. Make sure you click like and subscribe, and tune in next week as we tackle a really interesting topic, Blink versus the Vibe commit. See you next time.